This video is page 7 of your chapter 4 notes, reactions in aqueous solution. And it is decomposition and synthesis reactions. Decomposition, synthesis. These are ones that are just basically memorization. There's really not a process to them. There's just some straight memorization to these. So we will not have to know all these. Some of them are repetitive, but I want you to know a few of them. So first thing, if carbonates decompose, so this is solid carbonates, okay, not an aqueous solution. Okay, not an aqueous. So it should say that. I would always say, hey, this is solid Na2CO3, so it's together as a molecule. So it's not split apart. So I didn't do a good job of putting that on there, but if I give you something like this, I will always say this is a solid. It is not dissolved in water, so it's not split apart into ions. Carbonates, when they decompose, you take out a carbon dioxide. Anything with a carbonate in it, pull out CO2. So it starts to produce CO2 gas. Okay, CO2 gas. And so you just take CO2 out of that, whatever's left over, which in this case is Na2O, is what's left over. So like magnesium carbonate would produce carbon dioxide, magnesium oxide. None of these things are broken apart because it's not an aqueous solution. Okay, not an aqueous solution. Plus, this doesn't dissolve, it's a gas, and oxides don't do a good job of dissolving. So that's one thing. Chlorates, again, this is a solid chlorate. Okay, a solid chlorate. So solid potassium chlorate, if you just heat it, okay, they're being heated here, it decomposes, same thing there. You heat this, it decomposes, it produces oxygen gas. So carbonates produce CO2, chlorates produce oxygen gas as they decompose, plus KCl. Okay, not KClO, just KCl. So those are just memorization things. Again, not dissolved because it's not an aqueous solution to start with. Okay, it's not in water. These are just in solid things. And it would say that in a problem. It would say solid potassium chlorate is heated and decomposes. Solid sodium carbonate is heated and decomposes. I don't know why those extras are there, by the way. This is not balanced. I don't know. I would need a 3 there, a 2 there, and a 2 there. So not that big a deal. But you do need to be able to balance, hopefully. You do need to be able to balance. Letter C, I'm going to cross off. Don't worry about ammonium carbonates. Okay, they do produce CO2, just like other carbonates do, but do not worry about ammonium carbonates, so get rid of that. So we got carbonates and chlorates, carbon dioxide, oxygen gas. The next 3 all go together. They're all the same thing. These are all weak acids. Weak acids being heated and decomposing. Okay, so these 3, I guess they're just acids in general, decomposing. So acids in general produce a non-metal oxide. Think about it. Acids never have a metal in them. Think about all the acids you know, like here's an acid, here's an acid, there's an acid, HCl, HBr. They never have metals in them. Acids never have metals in them. So acids produce water when they decompose, and the non-metal with oxygen. Okay, now if you don't know what non-metal oxide it is right now, I'm going to tell you this for just a simple rule. Just make it balanced out. So if you take a water out of this, if you take out 2 hydrogens and an oxygen, whatever's left over is the gas that's produced. Okay, so acids in general, a non-metal oxide, water, non-metal oxide, water, non-metal oxide, water. Now just the opposite is going to be true too. If we put together a non-metal oxide and water, we get an acid. Put a non-metal oxide together with water. So when we do synthesis, it'll be just the opposite. Okay. Again, not worried about splitting apart into ions in this case for these decomposition reactions. And it will say that. Something's decomposition, not going to worry about any ions. Okay, next one. A base, so like calcium hydroxide, so any hydroxide will produce a metal oxide in water. So bases always have a metal in them. Think about it. Lithium hydroxide, sodium hydroxide, potassium hydroxide, barium hydroxide, calcium hydroxide, magnesium hydroxide. They always have a metal in them. So bases, when they are decomposed, so if it says decomposition of a base, produces a metal oxide plus water, whereas acids produce a non-metal oxide. Okay, the opposite is going to be true again. If you put a metal oxide in water, it produces a basic solution. So that really should be what you have to know. Any binary compounds, this shouldn't be something that's different from normal, but if I say, hey, we're going to decompose aluminum chloride is going to decompose. Well, it's going to decompose into aluminum plus chlorine. So any binary compound will split apart into its elements. Again, not in aqueous solution, so not dissolved for these decomposition things. So we're not worried about things being ions and being dissolved. One special one, hydrogen peroxide. Decomposition hydrogen. So you pour hydrogen peroxide on a cat, it starts to bubble. Know that bubble is oxygen gas. Those bubbles are oxygen gas coming out of hydrogen peroxide. This is not balanced. Again, it would need a 2 and a 2. Same thing with this one. They didn't balance them. Okay, I would expect you to balance them. But hydrogen peroxide does produce oxygen gas. All right, there's your decomposition ones. Those tend to be the hardest ones because you have to memorize. So you got carbonates produce carbon dioxide gas and they decompose. Chlorates produce oxygen gas and they decompose. Acids produce water plus a non-metal oxide. Bases produce water plus a metal oxide. There's kind of your 4 major ones there. Synthesis reactions, kind of just the opposite. Okay, so first thing, if I give you a metal and a non-metal, it just produces a compound. So if I give you, if I said iron is going to react with bromine, metal plus non-metal, it's going to make iron, let's say it's iron 3, so FeBr3. If it was iron plus 3 charge, you would need a 2 and a 3 and a 2. Okay, so synthesis, again, not an aqueous solution. That should be easy. If I give you a metal in that and say, hey, they synthesize, they come together, make a compound. And then these next 2 are just opposites ones up there. Metal oxide, water, makes a base, has hydroxide in it. Just like we said up there, when a base decomposes, it produces a metal oxide plus water. And then non-metal oxide plus water makes an acid. If you're not sure what acid right now, that's fine. Just combine this. Just combine it together. Put all of it together so you have 2 hydrogens, 1 sulfur, and 3 oxygens. If you get the wrong acid there, I will be fine with that for right now because we're just trying to learn this stuff as we go on. So there's your 3 kind of synthesis reactions. Again, not an aqueous solution. And then last one that you guys, I think, know pretty well, combustion reaction. So hydrocarbon combustion. Not everything's hydrocarbon combustion. We could say we have the combustion of magnesium. So the combustion of magnesium would be magnesium plus oxygen makes magnesium oxide. You need 2 and a 2 there. So hydrocarbon combustion would be something like propane. So a hydrocarbon, anything with carbon, hydrogen, or could it be carbon, hydrogen, oxygen as well? If those combust, CO2 and water. Again, we're not an aqueous solution for these decomposition synthesis reactions. So if we see decomp synthesis, you don't have to worry about any ions being split apart. Obviously, we need to balance that. You got 3 carbons, 8 hydrogens, so we need a 4 there. 6 oxygens and 4 oxygens is 10, so we need a 5 right there. And so hydrocarbon combustion, CO2 and water, which I think you know. Those are kind of a lot to remember, but you can break it apart and break them down and hopefully figure out which ones are which. Remember, there's a couple decomps, the acid-base ones. The opposite is also true for synthesis. Peace out. Have a good day.